Hi guys, we are finishing up chapter 4. I believe there are only 3 sections in here. Let me check. I'm a little bit crippled here. Yes, okay. So we're finishing up chapter 4. There's only 3 sections in here. Before we move on to section 4.2, 4.3, we're going to review 4.2, which was the binomial distribution. Remember, we used our calculators to get that. Before we move on to the different types of discrete probabilities, we're going to review the binomial, just so we remember how to use our calculators and how to find those probabilities. So I'm looking at number 19 in particular on page 211. Okay, so number 19 says 56% of men do not look forward to going clothes shopping for themselves. You randomly select 8 men. Okay, so we're looking to find the probability that the number of men who do not look forward to going clothes shopping. That is our p-value. So that is going to go in as 0.56, and we've chosen 8 men. That is our n value. Okay, so we're going to open up that program on our calculators, hit second 0, and then your apps button, and arrow down to binom PDF and click enter. The first thing that goes in is our 8, which is our n value, 8, comma, then the p, which is 0.56, comma, and then the first value that we are going to test is 0. So 0 and then enter. Because what we're going to need to do is we're going to need to find all of these values from x equals 0 to 8 in order to answer the question. So we're just going to make the whole table for all of the n values. So when x is equal to 0, our probability is 0.001, 3 decimals. So we'll do it again. Second 0, apps, down, 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 enter. Then our n value is 8, comma, our p value is 0.56, comma, and then x is equal to 1, hit equals, and we get 0.014. I'm going to do this one more time. Second 0, apps, down, 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 enter, 8, comma, 0.56, comma, 2, enter. And we get 0.064. Okay, so finish that table on your own. Pause here if you need to, which you will, and finish that table on your own. Now, assuming you've gotten that table all filled out, this is what it should look like for number 19. Okay, so we're going to look at what the problems are that we need to solve for that. Part A says, find the probability that the number of men who do not look forward to going clothes shopping for themselves is exactly 5. Well, this right here is your exactly 5. So the probability for 19A is 0.263. Easy enough. Now, for part B, we're looking at more than 5, which is 6, 7, and 8. And in order to get the answer to that, you have to add those numbers together. So 0.167 plus 0.061 plus 0.010 is going to give you 0.238. Please check that. And then part C, you're looking at most 5. That means everything less than 5 and including 5 will give you the answer to C. add up all of those probabilities, all 6 of them, and that should give you 0.762. So definitely check that and make sure that you get those same numbers. Okay, now we're moving on to 4.3, where we have a couple of other discrete probability distributions. The first one being geometric. So what I'm going to do is cut this down so it makes more sense, okay? We have the geometric, and this section here is pivotal because this section has you trying to determine, am I using the binomial distribution for this particular problem? Am I using the geometric distribution for this particular problem? Or am I using the Poisson distribution for this particular problem? When you're using the geometric distribution, you are going to be looking for a p-value and an x value. Okay, so let's go to the first example here. And it says we're going to jump down to, or jump up on page 218 to the and then I'll show you how to use your calculator. We're just going to be doing strictly calculator work. Okay. Try it yourself 1 goes off of example 1. It says basketball player LeBron James makes a free throw shot about 75% of the time. Okay. In other words, the favorable outcome of making that free throw shot is our p-value. So p is 0.75. Okay. Actually, that's the example. This is what you need for a geometric probability distribution. So the try it yourself 1, our p-value is 0.75. Now we are looking for the probability that he makes his first free throw shot before his third attempt. In other words, we need to find x equals 1 and then x equals 2, okay? Because he is going to shoot, so 0 here is not going to be one of the attempts, okay? He has to actually throw the ball to make an attempt. So x equals 1 and then x equals 2. So for the geometric probability distribution, you are going to hit second, 0, and then your tan key. So geometric, second, 0, and then your tan key. From there, you will arrow all the way down to geomet, PDF. Okay, and then from there, you'll hit enter. Now, what you need to enter in is just your p-value and then whichever x value you're using. So we'll open up that geometric probability distribution formatting. Our p-value will go in first, 0.75, comma, and then our x value of 1, and we'll hit equals. So when x equals 1, the probability is 0.75, okay? Now we'll do the same thing for x equals 2. Second, 0, the tan key, arrow, arrow, arrow down, hit enter. The probability p-value, or the p-value is 0.75, comma, and then x equals 2, hit equals, and you get that probability is 0.1875. So the probability of him making his first free throw shot before his third attempt is found by adding those two things together. So 0.75 plus 0.1875, and that is equal to 0.9375, or about 94%. Okay? So within the first one or two shots, he's more likely than not, to make that free throw. Okay? So that is your geometric distribution. You definitely want to write that down. Just like in our binomial, you definitely want to write this down. Okay, the last discrete probability distribution we are going to use is the Poisson distribution. And for this one, this is named after a guy. Okay, for this one, you'll need the mean, the p-value, and the x value. Okay, so for the Poisson, you'll be using your mean, your x value, and the p-value. Okay. Or I'm sorry, you're just going to be using the mean and the x value. You don't even need a p. Okay, that'll work out well. Okay, so the mean and the x value. So we're going to look at the example 2. Let's look at the example that they give us. The mean, we're on page 217. The mean number of accidents per month at an intersection is 3. So we're given that our mean is 3. What is the probability that in any given month 4 accidents will occur at this intersection? So our x value is 4. That's all we need for the Poisson distribution. Forget the p-value. Again, that's how you're going to be able to distinguish between, is this problem going to use the Poisson distribution? Is it going to use the geometric distribution? Or is it binomial distribution? The binomial uses the n value. The geometric and the Poisson do not. The geometric uses the p-value but no n. The Poisson uses the mean, and neither the binomial nor the geometric use the mean. So we are going to open this up on our calculators. Second 0, so here's the instructions. Second, whoops, hold on one second. Let's get a decent color here. The second key, the 0, and then this time you're going to hit the number 8, okay? That will bring you down to your p's. Then you're going to have to arrow down quite a bit of times to get to your Poisson PDF. And then from there, you're going to hit enter, okay? And that's going to open the Poisson PDF with your parenthesis. So what's going to go in there is your mean and your x value. And that's it. So in solving this problem, when we open up the Poisson distribution, we enter 3, 4, and hit enter. And we get that the probability that in any given month 4 accidents will occur at that intersection is 0.168. Okay, so this is what you need to remember for that particular distribution type. Okay, so your question might be, how in the heck am I going to be able to tell the difference between the 3 of them? Okay, here's where the good stuff comes in. We're on page 221, the homework section for 4.3. Now, starting at number 11, it says, find the indicated probabilities using the geometric distribution, the Poisson distribution, or the binomial distribution. You need to be able to determine which one of the 3 each one of these homework problems is, and then find that probability. So we're starting with number 28, or number 24. Pilot test. The probability that a student passes the written test for a private pilot license is 0.75. Okay, so that is our p-value, because we want to pass. That is the preferred outcome, 0.75. Okay, reading on. Find the probability that the student passes on the first attempt. So even just by looking at 24A, we don't have a mean and we don't have a specific number of people that we are picking randomly. This is an X value, okay? Whoops, this is an X value, which would be for 24A, X equals 1. Okay, let's go back here. For the Poisson, we need the mean. That's not it. The geometric, we need the P and the X. Well, we have the P and the X. That means that 24 is a geometric distribution. Okay, and this is what we are going to need to open up on our calculator. So, second, 0, tan, arrow, arrow, arrow down, enter. Then you put in 0.75, comma, 1 equals, and you get that the answer to 24A is 0.75. Okay, now we are going to look at number 25. 42% of adults say they have cheated on a test or an exam before. You randomly select 6 adults. That is your N value. So the probability, or the P value, is your 0.42. The N is 6, and then find the probability that the number of adults who say they have cheated on a test or exam before, that's why 0.42 is your p-value, is exactly 4. Okay, so if we scroll back through, it's not the Poisson because we don't have a mean. It's not the geometric because we're missing the N. Here, it's binomial. Okay, that's how we can tell. So the binomial then is second, 0, apps, arrow, 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 enter. And then remember here, it's your N, so 6, comma, 0.42, comma, and 4 equals. And you get that probability as 0.157 for 25A. See the difference here? That is binomial because we have an M or an N value. Okay, now for 26, oil tankers. The mean number of oil tankers at a port city is 8 per day. So we have a mean. We don't have a number of oil tankers that we are randomly selecting, okay? We don't have a given p-value. We're just told to find the probability that the number of oil tankers on any given day is, for 26A, exactly 8. That is Poisson distribution, okay? So second, 0, 8, arrow down until you get to your Poisson PDF, hit enter. The mean goes in first, so 8, comma, the x goes in next, 8 equals, and you get that's 0.1395, 0.1395. So if we round to 3 decimals, it would be 0.140. That's how you tell the difference. Okay, so the homework for this is going to be 2, 4, 6, 8, and then 11 through 23, all of them. So what I want you to do is identify this particular information. Like you'll read number 11 and you'll say, oh, my n value is whatever. My x value is whatever. My p value is whatever. Choose, according to the given, what distribution you need. Identify that distribution and then give me the answer. So for example, number 24. This is you doing your homework. Okay, I'm on 24. The probability that a student passes the written test for a private pilot license is 0.75. Ah, I know, that's my p-value. Find the probability that the student passes on the first attempt. So 24A, I have that x equals 1, okay? P and x, I know, is geometric. So I am going to identify this as geometric. And then use your calculator to find the answer to A and write your answer just somewhere down under A, okay? That's how I want you to do your homework. So again, 2, 4, 6, 8, and then 11 through 23, all of them. All right, have fun with this, guys.